Welcome to a third part for 8.1 and 8.3. I want to talk about some general examples of simplifying rather than just taking the square root of things. So in other words, what happens when we have to deal with the square root of a variable? So specifically, if we have this, we have the square root of x squared. Remember, square root is asking what number is being squared. So what would you say is the square root of x squared? Well, most people say x, but the answer is actually the absolute value of x. Remember, absolute value means it turns a positive to a positive and a negative to a positive. So it always gives a positive answer. But why? Well, the answer actually goes back to what we already talked about earlier. We mentioned that a square root of a number is always positive. So we want to get a positive square root. We don't know if I have something like x squared, we don't know what number is being squared. That could be a negative number. If that's the case, I have to take the positive version of it. That's why we have to do these absolute values. You'll notice in some of the problems it says assume that the number is non-negative, meaning you don't have to worry about the absolute values. But if that is not stated, you need to include the absolute values. So to kind of demonstrate this, let's just do an example. Take the square root of 25x squared. Well, based on what we've already talked about, we can kind of look at this and actually we can focus on what's the square root. This will lead into actually the next section, but I can focus on each part. So what's the square root of 25? Well, the square root of 25 is 5. What's the square root of x squared? We just talked about it. It's the absolute value of x. So, and this idea about how to break up the square roots will make more sense in 8.3, but this is a general idea that we're coming across. So let's try this one. I want you to take a moment and see if you can find the square root of that. Go ahead. Well, hopefully, as you looked at this, you realize that 64 is the square root of 8 times 8. So it's going to give me 8. The square root of x to the fourth is x squared times x squared. So it's going to give me the absolute value of x squared. So whenever I take the square root, it's got to give me the absolute value. Well, let's switch it up and let's go to a cube root. Can you take the cube root of these? Go ahead and pause the video and try it on your own based on everything we've talked about thus far. Welcome back. Again, you can use the thing that I just mentioned previously where it can break it up into different parts. Let me ask you a question. What's the square root of 27? And any of these? Well, 27, notice, is 3 times 3 times 3. X cubed is x times x times x. And y to the 12th, because I can actually divide that number by 3, I get y to the third, y to the third, y to the fourth, y to the fourth, and y to the fourth. If I do that, what's the cube root of the first one going to be? It's 3. What about this? That's x, and this is y to the fourth. Now you might be pausing and saying, wait a second, where do my absolute values go? If it is a cube root, we don't need those because remember, a cube root could be negative because the cube root of a negative is a negative. The cube root of a positive is positive. So if this is an odd root, there's no absolute values. If this is an even root, you have to include the absolute values. So please keep that in your mind as you move on, and hopefully this will make more sense as you practice it over and over. Please let me know what questions you have, and good luck.